So up here on the top left, for a prism, V equals capital B H. Okay? And everyone's writing this down. And for pyramid, it's very similar, but we're going to do 1/3 BH. Okay? So does everyone see the difference being the fraction, the 1/3? So, first one, we need to know what's B, what's H. Now, for B, capital B stands for what? Area of the base. So, this shape is a rectangle. How do I find the area if the length and width are 20 and 8? 20 times 8, length times width. Very good. So remember that. Capital B is when we're going to multiply, if it's a rectangle, length times width. So 20 times 8 is 160. Very good. Capital H, sorry, lowercase h. What am I saying? Lowercase h is what? Okay, it stands for height, and it is 16. So, height is 16. Now, I'm going to write the formula that I have up here, down here. Volume equals BH. And all we got to do is replace B and H. So let's do that. 160 times 16. Going to multiply those. Okay. And we got 2,560. Very good. What are my units? Okay, good. So centimeters, and it's to the third power because it's 3D. So centimeters cubed or cubic centimeters, okay? So that's it, right? Not too bad. If you know it's a rectangular prism, okay, you may have originally learned length times width times height, but that only works for a rectangular prism. So we use BH because it also works for other types of prisms, okay? Now, off to the right here, we got a pyramid. And we need to know B and H. So we need to kind of assume something here. Unfortunately, we don't like to assume. But if this is 32, we're going to assume this is a square. So the other side is going to be 32. So again, capital B means area of the base. How do I figure that out? Okay, yeah, 32 times 32. Okay. Yeah, we type it in. We see that we get 1,024. Good. Now, do we know the height? So, remember, the height would be from the tippy top straight to the middle, and it looks like this is labeled, actually, right there, 30. So, 34 would not be the height. That would be slant height, right? But we do know the height this time. So, now we have all we need. Let's write the formula. V equals 1/3 BH. So let's write this down. 1/3 1,024 times the height of 30. Okay. And to the calculator we go. I type in 1 divided by 3 times 1,024 times 30. And that gives me 10,240. And then my units, inches cubed. Okay. Run. We got 2 more to do. All right. So, are we good on the first 2 examples? Okay. The next 2 are a little trickier, but we can do them. Okay. So, moving it down. If you need the first 2, you can come back to it. All right. So, why would this one be kind of tricky? What do you think? I want you to notice its orientation, that the way it is facing is sideways, right? So everyone's eyes over here, looking over here. Eyeballs. Okay? So here's why. The bases that are parallel are triangles, right? So since the triangles are going this way, side to side, the height is going to be also side to side. It's kind of like when you lay down, you're the same height. It's just your height is sideways now, right? So this is a prism or a pyramid. What do y'all think? Prism. So I need to figure out capital B, right? So my base shape is a triangle, right? So how do I find the area of a triangle? Okay, very good. So everyone needs to know this formula. It's base times height, and then divide it by 2. If you don't divide by 2, you're not doing a triangle. Because Ms. Barrera wants you to know a triangle is half of a rectangle. From corner to corner, if you cut it in half. If you cut it from diagonal to diagonal, you get a triangle. Okay? Or corner to corner, I should say. Okay. In this case, we don't need to use any Pythagorean theorem. So what is the base? 12. And what's the height? 16. So 12 times 16, don't forget to divide by 2. Okay, so 12 times 16 divided by 2 gave me 96 on my calculator. Now this is where it gets tricky. The height of the prism is between the two triangles. Okay, so does everyone see, look right here, that the height is 10? Because it's like it's laying down, okay? So between the two triangles, that's the height. It's 10, okay? There's a difference between the height of the triangular base versus the height of the prism, okay? So there are different heights going on here. I get it. It can be confusing, but that's why I'm showing it to you, okay? So again, the height is 10 because it's between the two triangles. It's like your height is between your feet and the tippy top of your head, right? So think of the triangles as the feet and the tippy top of the head. It's laying down, so the height's between those. Just think of it laying down, like when we had a certain student do that in my class when we had a sub, right? Laying down right here. So I have it over here. So if you want a visual, okay, here's the height, right? Here's the height, right? The height is always from base to base. No matter which way it's shaped. Even if it's diagonal, that's still the height. Okay. We can explain more later if you want us to, but let's get through these notes. For a prism, it's V equals capital B H, right? From the top of this page. Okay. So, big B is 96. H is 10. Hopefully that's mental math. 96 times 10, 960. And what are my units? Centimeters cubed, right? All right. Now this last one is tricky in 2 different ways, right? Let me get that. So, what is this thing? So, first of all, it's a what? Okay, it's hexagonal pyramid. So I'm going to use my pyramid formula. First, I need to find capital B. Big B, the area of the base. Now, what is the shape of that base? A hexagon. Now, that is a hexagon, and a hexagon is a type of, starts with the P, polygon. Okay? Now, we did this school year. Now, maybe you weren't in my class, or you forgot, but we did this year. How do I find the area of a regular polygon? So, for this information, we refer to our formula chart. So if you're looking at your formula chart, right around here where it says regular polygon underneath area, you'll see that it says 1/2 AP. Now, who remembers what that little a stands for? Who's little a? Apothum, right? Sounds like a possum with a lisp. Apothum, right? So apothum is from the center of a polygon to a midpoint, right? So check it out. Do I know the apothum of this polygon? Yeah. here to here. So little a is 4. I need to figure out p. What's the perimeter of the bottom? 6 all the way around. 6 times 6 is 36. Very good. So now I can find big B. Area of the base is A times P divided by 2. So apothem 4 times perimeter 36 divided by 2. Don't forget to divide by 2. And we get what? 72. Very good. All right. Now we have big B, but now we need to figure out H, right? So H. Now, do I know the height? Who thinks the height is 16? You'd be wrong. Okay? So the height should be from the tippy top straight down to the center, and it is missing. But I got a right triangle with a leg of 4 and a hypotenuse of 16. So guess what wild thing we're going to do right now? Pythagorean theorem. Okay? So let's find this x right here. So I'm going to set it up. X squared plus 4 squared equals 16 squared. And we do what we did before, where we square them, subtract them, square root them. Okay? So 4 squared is 16. X squared plus 16 equals, and then 16 squared. All right. True. 256. And then we have to subtract 16. We're missing a leg. That's 240. And then, last step, square root. What is the square root of 240? 15.5. Very good. So, calculator is your friend when you do those. So we finally got our H. Now, I know this problem has a lot of weird stuff in it, but you can find the area of a polygon, and you can do Pythagorean theorem to find the height. So let's write down our formula. For a pyramid, what is it? Okay, 1/3 BH. It is. So replace B with 72. Replace H with 15.5. All we're doing is plugging in B and H, and we're going to get our answer. Okay. So, plug it in. I got 372. And my units are meters cubed. Very good. Now, with our couple minutes we have, kind of like last time, again, mini Hulk, you want to separate your assignment from your notes. Again, the second page, you got 4 prisms, 4 pyramids, right? And you can do those the same way we did them on the notes. When you get stuck, or if you get stuck, you let us know. But I want you to work on it till the bell, and tomorrow is another day to work on this, okay? Before we move forward into spheres. Woo!